Hey there, and welcome to DIY Projects with Pete. In today's episode, we'll walk through the process of how this cable railing system was built from scratch for my TREX deck. I built it out of 2-inch square tubing, cut it to size, welded on a top and bottom plate, added some cabling, and then 2x6 cedar boards for the top plates. Now this project took 2 full weekends to do, one to build everything and then the other to install it. And I chose cable railing because it doesn't obstruct your view. I think it looks real clean, and then it also tied in with my house really well. And even after buying a few additional tools, I still saved thousands of dollars and feel it was well worth my time, and the project was really rewarding. Now I hope this video inspires you to build your own deck railing, and if you find the video helpful, please give a thumbs up and subscribe to the channel. And if you have any questions for me, or ideas or tips, or if you'd just like to share about the deck project you're working on, please comment below. Also, I'll have more information in the description, as well as on my website at DIYpete.com/cable railing. All right, let's go ahead and get started with today's project. I picked up square tubing and flat bar from our local steel yard. I got 5 20-foot sticks of square tubing and 22 feet of flat bar. Now for this deck, I had about 115 feet of railing that needed to be made. And I started by cutting down the 1/4-inch thick steel flat bar into 4-inch by 4-inch squares on the metal cutoff saw that will be made into the top and bottom plates for each post. The metal squares will later have holes drilled into them and then be welded to the square tubing. You'll want to take your time with this process to ensure each piece is clamped in securely and cut square. The 2-inch by 2-inch square tubing was cut down to size, and you'll want the minimum total height with the top rail to be at least 36 inches to meet code. I'd recommend the total height to be somewhere between 36 and 42 inches, depending on how it affects your view while sitting down in a chair, and how high you'd like it in case you want to lean on it or set your cup of coffee on the rail. I determined the number of posts needed by measuring the total distance for each section and then dividing by 4 feet. The posts would then be spaced as evenly as possible between each corner post, and I'd recommend a maximum of 4 feet between each post. Now, some posts may need to be adjusted in spacing a bit to work around a joist or other obstacles. Now let's talk about cost, because cost may be a big factor as to why you might want to build your rail system from scratch, or at least part of it. When doing a quick search to get a rough idea of the cost, the first estimate that popped up said cable railing would be in the neighborhood of $60 per linear foot installed, or $35 per foot just for the materials. Using these estimates for my 126 linear foot project, which is a large deck, it would be around $4,410 for the materials, and with labor added to it, it's estimating the system would be about $7,560 total. Now there are a lot of variables, and a big one is the material the posts are made of, but I wanted to compare a few options that I came across. Prices vary, but a lot of systems I found online were easily in the $6,000 to $10,000 range plus labor, and some are stainless steel or aluminum posts that look pretty fancy, but mine have done the job just fine for a fraction of the cost. I was able to find some pre-made posts online with holes already drilled, mostly in the $100 to $200 range, and if you don't have welding skills or the time to make all the posts, this could be a great option, and you'll still be saving money over buying a big package deal. Using this method, I'd have spent about $3,200 for posts, which doesn't include the cable hardware or cable, but you can calculate that by adding my actual costs on cable, hardware, and rail tops to get a good estimate. Alright, so now I'll share my costs to add railing around my entire deck. With 126 linear feet of railing, including the steps, here's a breakdown of my cost for the complete railing system. And for an even more detailed breakdown and links, check out DIYpete.com/cable railing. This brought the total rail system project cost to $1,545 and about 2 full weekends of my time. The average cost per linear foot building this from scratch was $12.26. Now, I just wanted to give you an idea of costs so you can further research and figure out the best route to go if you're planning to do your own cable railing. Scrap 2x8 boards were screwed together using 2.5-inch long deck screws to make the blocking that the posts will bolt to. They fit snugly between the joists and can be tapped into place using a hammer, and then secured using long decking screws from the sides or areas you have access to. Blocking can also be added after the decking has been installed, as you can see me doing in this footage. I used a miter saw and a table saw to get the boards cut down to fit each space. I then secured each board in place with plenty of 4 to 5 inch long deck screws. Now, if you're interested in checking out how the deck was framed and built, you can check out the link in the description below. Around a few sections of the perimeter where the deck was laid down in a picture frame style, the blocking boards were cut to fit around some of the framing. Joist or beam protective tape can be added to the top of the blocking to help protect it from the elements. Now we'll get back to working on the railing posts out in the shop. The total height of each square tubing section was 36 inches, including the top and bottom plate. Now I'm using 9 sections of cable, which is going to create 10 open spaces. So I took 36, divided it by 10, and then the spaces turned out to be a little more than 3.5 inches between each cable. Now, they can't be more than 4 inches apart for the building codes in many areas, so some folks will recommend spacing them 3 inches apart since the cabling can flex when pushed on, so you may want to add an additional section to meet code in your area if it's going to be inspected. I then found the center point on the template where the hole will eventually be drilled for the cable. Here I'm using a small drill bit in my drill press to create holes in the template that are just big enough to put the tip of a marker through to mark each hole location. The template was then set on the tubing and I marked each hole. The next step was to drill through the tubing. I used a 1/4 inch drill bit which will fit the cable railing hardware that I picked out. If you're interested in the cable railing hardware and cable I used, you can find the links in the description below or in the detailed post at DIYPete.com. You will need to invest in a drill press for this project if you don't already own one, as you'll be making a lot of holes in the metal and they need to be straight. A drill press will also provide the down pressure to make drilling the holes easy. I had 28 rail posts to drill holes in for the main portion of the deck, so I figured out the most efficient process, and I did all the posts before moving on to the next process. I continued to work on making the posts by using the template to mark for the holes and then drilling them. 9 holes were drilled in each post all the way through the tubing. I then labeled the top and bottom of each post. Originally, I'd planned to do 1 post at each corner, which may work if you have a real small deck. I didn't end up using these posts, but I figured I'd show the process in case it worked out for your situation. As you can see, I drilled a hole on 2 different sides, and the 1/8 inch cable feeds in through the 2 sides fairly easily with a little bend on the end to help it go through. Using the 2 posts at each corner helped ensure I could get plenty of tension for each section, and I was really happy with this technique. Using the 2 posts at each corner helped ensure I was able to get plenty of cable tension for each section, and I was glad I went with the 2 posts as it still looked good, and the overall railing system is nice and solid. The next step was to build the top and bottom plates for each post. I needed to cut a few more plates, and I found that cutting them vertically in the saw was a little faster than cutting them when they were placed flat in the saw. The squares were each cleaned up using a flap disc on an angle grinder to smooth over the rough edges. A 3/8 inch bit was used to create a hole in each corner of the bottom plate. I then used this plate as a template to mark the rest of the plates. The drill press is going to provide the down pressure to get the holes made rather quickly. I was able to drill about half of the plates before the bit needed to be changed, and as you can see, once a bit dulls, it takes a real long time to drill a hole. Instead of having to buy a bunch of bits, I used my Drill Doctor bit sharpener, which is a super handy tool to have. It saved me money, but it's also saved me a lot of time since I don't have to go buy a new bit when one dulls. You basically set the bit in the jig to the proper setting, then place it into the sharpener, and a drum inside will sharpen the point after about 5 to 10 turns. You then place it into the side to sharpen the other angle, and then you'll have a nice sharp drill bit that will work like new, and it only takes a couple minutes to sharpen it. I placed the post on the center of the bottom plate and then tacked it to hold it in place using the welder. This is an old flux core welder that I've had for years. I originally bought it to build table bases and to fix things, but it's been an awesome tool to have. It plugs into a normal household outlet and doesn't require gas, which makes it easy to get started in welding. After tacking in place, I welded a bead around all 4 sides to create a solid connection. Here's an up-close shot of the welds before cleaning them up. A flap disc was used to clean up the welds, rough edges, and then areas where holes were drilled in the square tubing. The top plate was made similar to the lower plate, but with smaller holes for wood screws that are used to connect the post to the top cedar rail from the underside. The post was then set on the top plate, tacked, and welded around all four sides just like the lower plate. A flap disc was used to remove rough edges and to smooth things out prior to preparing the posts for a finish. The metal needs to be degreased prior to adding a finish so that the paint, sealer, or powder coating will bond properly. I wiped the metal down with acetone and used a blue Scotch pad and rag to remove it as best as possible. Our local powder coating companies were about 3 weeks out, and I just wanted to get the deck railing complete. But if you have the time and can plan ahead, I'd recommend having the posts powder coated for a longer lasting and a more durable finish. I was quoted anywhere between $200 and $300 to have all of the posts powder coated with a matte black finish. I did about 3 coats of Rust-Oleum matte black spray paint on all sides of each post. It sprayed on evenly and turned out looking really good. I gave the posts plenty of time to dry and then took them out to the deck. They're placed about every 4 feet apart, and then blocking will be beneath each post. I did a little testing and completed that first side just to see how things went, and it ended up going together smoothly. I marked and then drilled each hole with a 3/8 inch diameter drill bit. A total of 4 3/8 inch diameter, 5 inch long galvanized bolts are used for each post, with 4 washers on the top side, and then 4 washers and 4 nuts on the underside. Here's an up-close shot of the galvanized bolts I used, and I did try using leg bolts to see if they'd provide enough strength, but they didn't, and I'd recommend only using bolts that are secured with either washers or a plate, and then nuts from the underside. Try to buy your bolts, the nuts, and washers in the boxes since they're going to be much cheaper than buying individually. Now that the first section was up and I worked out the kinks, I moved on to the next section. I put together a diagram to show how I determined the placement for the posts. As you can see, the decking overlaps the fascia board by a 1/2 inch and the rim joist by 1 1/4 inches. The fascia board is basically the decorative board that covers the pressure-treated framing and makes it look nice. I used 3/4 inch thick cedar for this deck. Now I've added the joists and blocking to the diagram. The post must be placed in a few inches from the edge so you'll be able to put the bolts through the blocking and have room to secure them with a washer and nuts from the underside. The blocking is a total of 3 inches thick when sandwiched together, and the decking adds about 1 more inch, plus the 1/4 inch thick metal plate. So the 5 inch long bolt will go through the 4 1/4 inch total thickness with plenty of room for the washer and nut. Centering the post over the gap between the boards worked well. I thought it looked the best, and it provided an even surface to mount the post to. Now, one of the most important steps is to level each post as it's installed. Not all decks and boards below the post are going to be perfectly level, and how level the post is will change a bit as you tighten it down. Once the bolts were secured in place, I used a socket wrench on the top side and a wrench on the underside to tighten each bolt, periodically checking the level. You can use a couple washers between the decking and post space if it needs to be shimmed slightly. I did the corner posts of each section first. I'd mark the hole locations with a Sharpie and then drill each hole. And you'll want to use a fairly long drill bit so you can easily go through the decking and the blocking. I used .120 thick square tubing, which is about an 1/8 inch thick for all corner posts, and then I used .083 thick square tubing, or about 1/16 inch thick for all the inner posts. The thicker tubing may be a bit overkill, but I wanted to make sure I'd never have any issues with posts bending or flexing. Then I moved on to marking the holes for the inner posts. For more accuracy drilling the holes, use a smaller bit before you use that larger diameter bit. Then insert the hardware and prepare the rest of the section to be tightened down. Take your time and double check that the cable holes are all pointed in the correct direction prior to installing them. Again, we'll level each post and then tighten the hardware. I ended up using an impact wrench with a socket on it to speed up the process. Have a few extra galvanized washers around in case you need to do any shimming underneath the post plate. Just a quick side note, next time I'll try and figure out a different spot for the camera since it vibrated every time I hammered or attached posts. Sorry about that. The next step was to get an idea on how I was going to do the top railing and how I was going to start laying it out. I used 2x6 redwood cedar boards that I'd picked up from my friend Kevin over at Emmer Brothers Cedar. Once I had a good idea of how the railing would work out, I finished installing the remaining sections of the deck. I used a combination of 14 and 12 foot long 2x6 boards for the railing. A 30-degree bevel cut was made where each board would connect to the next, and a 45-degree miter cut was made at each corner. 4 beefy 1.5-inch long construction screws were used from the underside to secure the top of the post to the railing. The posts are super secure, but I still like to add the top rail prior to adding the cabling just to help prevent the corner posts from ever leaning in due to cable tension. I had a lot of questions about the cable railing process, but after getting started, I found that it was actually really easy. It went quick, and it was a lot like adding icing on the cake, which I've never really done, but it made it look good. The 1/8-inch thick stainless steel cabling slides through the 1/4-inch holes easily, and you simply run it through each post until it gets to the corner post where the hardware is. I ordered a hydraulic crimping tool on Amazon to crimp the cable into the hardware. Simply turn the dial on to start crimping cable, and once done, turn the dial to the left to release it. When the cable is pushed all the way into the hardware, put the crimper around it, and you'll squeeze the handle about 4 to 6 times to secure the cable in place. Here's a shot showing the second cable going in, but on the other side. The hardware gives you some wiggle room, and you'll basically pull the cable tight to line it up with the hardware, then cut it with a cable cutter. Next, feed it into the hardware and crimp it just like you did on the other side. And once it's connected, you can tighten the hardware by hand by just turning the bolt. Continue feeding each cable through until this section is complete, and you can find links to the crimping tool, cutter, hardware, and cable railing in the description below or at DIYpete.com/cable railing. Tightening it by hand will look good, but you can always tighten it more using a wrench. Next, I started working on the railing for the steps, and there are a lot of different ways to do the railing, of course, but I figured I'd show the method I used in case it helps out with your project. First, I calculated the approximate angle of the steps by using a long board and an angle finder, and it turned out to be about 32 degrees. I cut that angle for the top of all 4 posts using the cutoff saw, and I adjusted the height just a bit so the railing would go underneath the deck's railing and have nice spacing. I then cleaned up the cuts, used a magnet to hold the metal in place, and finally welded a plate to the top. The posts were then mounted to the steps in a similar fashion to how the other posts were mounted on the deck. I did not have blocking on the steps yet, so I did need to remove a few of the lower boards to add blocking under the post areas. For the lower step, I did need to use some shorter bolts so I had room to get the hardware in underneath, and it was a little bit tricky, but it went just fine. The posts were centered over the gap between the boards and then placed in about 4 inches from the sides of the steps. Holes were drilled, and then each of the posts were leveled and the bolts were tightened up. The 2x6 cedar boards were cut with about a 4-inch overhang on each end and bevel cut to match the step angle. They're attached to the angled posts using the same 1.5-inch long construction screws used for the other posts. Now that the steps were figured out, I moved back to the deck to finish up with the top rails and cabling. One big reason that the posts are mostly 4 feet apart or closer is to prevent the 2x6 boards from sagging over time. There was one section near the steps that was a little wider than 4 feet due to needing to work around some joists, but I think it will be just fine. I was really happy with the hardware I picked out because it gave the cabling a very clean look, and it was about the most affordable hardware I could find on the internet. I wanted to seal the railing to protect it from the elements, and before sealing, I used 120 grit sandpaper to round over the edges and to smooth out the boards. I like to lean on the railing sometimes and set coffee on it, so I didn't want anyone getting slivers. Now I wanted to quick share a photo my mother took of my dad and I at the deck railing looking out over the mountains while he gave me some life advice right after I'd graduated from college. That brought back some really special memories, and I hope some life lessons and good talks are had out on this deck and on your patio as well. After sanding, dust was wiped away and I began brushing on a sealer. I didn't want to darken up the wood too much, so I used a clear water-based deck stain and applied a couple coats. It tied in real nicely with the siding on the house, and it provides a durable finish that repels the rain and snow. It took me some trial and error to figure out the best way to do the cabling for the steps, and I ended up going with this cabling that has a hinge to match any step angle. I originally thought I'd be able to use the same hardware as the rest of the deck, but it didn't look great and the angle was slightly off. So I ordered the hinging hardware and decided to use it instead. I started by measuring up about 3.5 inches or so for the first cable, enough so it cleared each step with a little spacing between. I then pre-drilled with a 5/32" bit and used 1-inch long galvanized metal roofing screws to attach the hardware. Once installed, I adjusted the hardware to give me a little extra wiggle room so I'd be able to tighten each cable properly. Attaching the lower cable on the bottom of the step was a bit trickier since I didn't have enough room for a drill to fit, so I ended up just drilling from the outside all the way through the metal so I wouldn't have to spend time removing the stair riser. The posts already had a few extra holes since I was originally going to do a different style hardware, so a couple extra holes here and there wasn't a big deal for me, and you can barely notice them anyways. I removed the railing so I could get a better angle pre-drilling and attaching the upper hardware, and then as soon as it was attached, I put the railing right back on. The hardware crimps on similar to the hardware used for the main portion of the deck, and then it tightens up either by hand or with a wrench. The big difference are the hinges and then how you attach them to the posts. I checked the measurements to ensure things were spaced evenly, and that was about 3.5 inches or so for my situation. I then measured to evenly space the rest of the cables and used a total of 8 cables for the step railing. I used a paint marker for a lot of the marking since it was easier to see than a Sharpie. I'd recommend buying a couple bits so you have an extra or two in case you snap any while you're pre-drilling the holes. I found it easiest to line the hardware up by drilling one hole, attaching the bracket with one screw, and then using the other side of the bracket to line up where to drill this second hole, then drilling that and putting in the remaining screw. I'd then repeat the process on that other post and adjust each piece of hardware so I'd have that little bit of play to easily tighten up the cable. I then crimped and cut each cable to complete the railing for the steps. The crimping, cutting, and tightening process goes quickly. Simply turn the buckle and then tighten the nuts to keep the cable tight. Lastly, I vacuumed up the metal shavings around the step posts and decided it was time to start enjoying the new deck and rails. All right, thanks so much for tuning in. I hope you enjoyed today's episode and that it inspires you to go out there and build your own cable railing. If you did find the video helpful, please give it a thumbs up and subscribe to the channel. And if you have any questions or suggestions or ideas for future projects, please comment below. Thanks again for watching. Cheers.